Question 24. Observe the picture of the various components and processes that contribute to the activation energy required to light a match. So we have a picture here, and then the question goes, which of the statements about these components or processes are true? Select all that apply. So we're going to be going through each of them and making sure that each of them are true. So let's go over the first one. It says here in A, as the match moves across the striking surface, its particles adhere to the surface for a short period of time. So when we're taking a look here, we notice that when you're striking a match, it does have to go through this striking process. So here's the part where you strike it to cause some type of, I guess, rubbing to each other. So that would be the match here. So we do see that happening. So that's actually occurring here. So that is occurring here. But when we see this other one that's kind of a little bit different here, it says as the match head moves across the striking surface, its particles repel the surface. Its particles repel the surface. So when we take a look here, we have nothing here that in this picture that's dealing with any type of charges or anything here. But that's why it's kind of hard to bring up the idea of repelling and attraction. And even when we look at matches, we don't see them actually, how do I say this, attracting or repelling each other though. This is mainly by actions of what we do ourselves though. So I can't say that the third one is correct though. But when we take a look at this letter C though, breaking the adhesion between the match head and the striking force causes particle vibration. Well, we're starting to learn that as you place this match with the match head onto this part that has a lot of friction involved though, we're starting to see there's a lot of vibration there. So much vibration. And you can almost think that the closer the matches are, I mean, you don't want to break the stick or anything though, but as they come closer and closer to each other, it causes vibration to make a type of reaction though. So we're starting to see this reaction. That's what the vibration is. So we can always say that easily C has to be one of them. But let's look at this next one, this repulsive force. Again, I don't know about this repulsive forces, but the repulsive forces between the match head and the striking surface causes particle vibration. There is no charges involved in here. There's no, this match is attracting to this striking surface, and all of a sudden now they just want to repel each other. There's nothing like that happening here. We just see a lot more vibration. So it's not C. It is not C. But let's take a look at this next one though. I mean, it's not D. Excuse me, it's not D. The energy of vibration provides the activation energy required to light the match. Well, we were talking about vibration. This is all vibration here. This is all vibration. As this match is moving, we're seeing a lot of vibration, and it is causing that activation energy to light the match. It is. That is what's happening. That's what's occurring. So we see that one though. And let's check out the last two. Usually if they look similar in writing, they're probably opposites from one another. And it says here, the thermal energy of the vibrating particles on the head of the match is transferred from hot regions to cold regions. The other one is saying from cold regions to hot. Well, when we're starting to learn about how heat works though, you need to learn or know that heat always travels from hot to cold. It's never from cold to hot. There's anything like that. Heat is the one that's moving though. So you always have to remember this theory that heat always disperses. So it always goes from hot to cold. And so when you look at the only two between these two, the only one that could be is So now we have all of these four answers.